So sometimes it'll go in and out of focus because there's not enough writing on the board. So sometimes if I put a line here or something, it'll help direct it and give it something to zoom in on. All right, so what am I doing on this function is I'm trying to figure out where is sine of square root 3 over 2 negative. So I got to think, well, what is the square root 3 over 2? And when I think of square root 3 over 2, I think of the 30, 60, 90 triangle, right? So the 30, 60, so this would be 1/2. This would be square root 3 over 2. And this would be 1, right? And that's the whole doing the unit circle piece, right? Okay? When I look at this unit circle, I want to think, when is this angle negative, or this side, not angle, this side negative? And remember, do you remember sine versus cosine in our, when we're thinking about the point on the unit circle?
Yeah.
And what was sine?
X.
Sine was x?
Or Y.
We're not sure.
Oh, yeah.
All right. Remember, cosine is your x, right? And the sine was your y, your up and down value, right? So the opposite side or the adjacent, right? So when we're talking about the opposite side being negative square root 3, that means that this opposite side had to be like this.
Yeah.
Right? So that this is negative. Negative square root 3 over 2. This would be negative 1/2, but we don't care about that part, right? We care about the opposite side for sine. Does that make sense?
Yeah.
But where else would it be negative?
When
if you-
X is positive. So on.
Yeah, where x is positive, right? So negative square root 3 over 2, right? Yet your x is 1/2, but again, we don't care about the x, we care about the sine, the opposite side. And we don't care about the hypotenuse, right? In fact, this is really going to right here, right? Sorry about that. We're really talking about this going on the unit circle. It's going to here. Let's go like this. Does that make sense? Is that better? Whereas this is 1, right? Because the hypotenuse is always 1. Okay? So our negative on sine is here. Cool?
Yep.
All right. So what does that mean? Well, that means that the angle is that far, right?
Yeah.
So how far is that blue angle?
240.
240. Or
300.
what's our
That would be,
radians?
would it-
Remember, 1,
No.
2, 3, 4,
4/3.
right?
Yeah, 4.
So
5 over
4 pi over 3. Cool? So that's the blue. What about the green or the red? However you want to look at it. When I go all the way around to this
300.
5 over 3.
3. Yes, this is 60 before 360, right? So we're at 300. Or, like you said, one more pi, 5 pi over 3. Right? And so that is what the angle can be between 0 and pi, 0 and 2 pi, right? Because it asks us between, theta is greater than or equal to 0 and less than or equal to 2 pi. And then people are like, what do they mean by that? And they're like, well, they mean in this distance from 0 to 2 pi, sorry, right? What angles could this be? Because we could go around 1,000 times, it could still hit those angles, right? So the reference angles is all that matter, right? Cool. So when these are negative, that's what this is talking about. Now, think about this one. If this would be negative, it would be the exact same problem. So the difference between these two problems right here, think of it like this. 2 plus blank equals 5, or 2 plus x equals 5. Remember when I asked you about that problem? And how many students would be like, I don't really get that. I get this one, but I don't get that one, right? And then that's kind of how this goes. Like students start to get this one, but they don't understand this one. And I'm like, they're the same, right? Porter.
So if we were given this equation on a test, we're supposed to find both areas of what it can be?
Right. And I want the answers always in both degrees and radians. I just want you to start to think about this whole thing, everything in degrees and radians, degrees and radians, degrees and radians. If you always answer everything in degrees and radians, you will not go wrong.
Yeah.
Does that make sense? No matter what, you're going to be right. You might have more information than you need, right? Than Mr. Bjorkman asked for, but at least you'll have it right. Does that make sense? Okay? Not to mention, think how easy it's becoming to turn them, right? Like you said 5 pi over 3 before you said 300,
Yeah.
right? I mean, the radians almost become easier. Does that make sense? All right, so I'm going to put that on pause, and then we're going to talk about tangent. Or should I keep the video going? Should I pause it? Do another video on tangent?
You can keep it going. Or,
What do you think is best for you guys?
Just keep it going.
Keep the video going?
Yeah.
Okay. So we'll keep the video going, and we'll talk about tangent. All right? So now, this is a little bit different. We're talking about when is it the same. So we're still talking about the unit circle, right? But let's draw a different circle, right? Because, it gets a little messy talking about tangent with sine and cosine, right? But it's the same thing. We're still talking about 0 to pi to 2 pi. Does that make sense? But in this case, we're talking about when is the opposite over the adjacent the same. Can you think of any kind of triangle that has the same two opposite adjacent sides?
45, 40.
Oh, yeah. That would be cool. All right. So, let's look at those real quick. Am I running out of time?
You still got.
You got time.
Okay.
Yeah.
So I got all those 45-degree angles, right? But we want it to be -1. Which means, remember, we're only looking at these angles. Does that make sense? This angle, this angle, this angle, right? We're only looking at those reference angles. Does that make sense? And then, so we're talking about this side over this side being the same, but one of them being negative and one of them being positive. Because that's how you get to a negative, right? Negative over a negative is a negative, right? A negative over a positive is a negative, right? So one of them has to be negative, one of them has to be positive. So in which problems, I can tell you right now, this is positive and this is positive, right?
Yeah.
But then this is negative. Right?
Yeah.
So a positive and a negative make a
Negative.
negative. So that would be negative 1, right?
Yeah.
So I know that this is negative 1. Tangent of this would be negative 1, right? The tangent at this angle, right, is equal to negative 1. Where would the other one be?
On the opposite side.
Here?
No, up top.
On top. Because this would be negative, right?
Yeah.
But this is negative. So when they're both negative, it becomes positive, right? So what we want is when this is negative, right? But this is positive, right?
Yeah.
And so then the tangent of the angle is going to equal negative 1. So these tangents would be 1. Does that make sense?
Yeah.
So that's something I would write down in my cheat sheet somewhere, right? Because that's a good one to have. To know where tangent's going to be 1 and where tangent's going to be negative 1. Does that make sense? So like here, tangent theta is equal to 1. And here, tangent theta is equal to 1. Gideon.
Oh, is it in the bottom left quadrant? Is it tangent theta equal to 1 because it's negative?
Yes.
So they cancel out and we can
Positive. Right. Opposite over adjacent, right? All right, so what angle is this though? We still didn't find that.
That'd be 1.
Let's use orange. So we're trying to find this angle and this angle, right?
Yeah. 135.
135?
Or, yeah.
So theta here would equal 135.
Or 3 over 4.
Right, or 1, 2 pi
Wait, it's 3.
over 3, right?
No, it's over.
Are you sure?
Wait, it's up 45.
Oh! I'm just checking. I just want to make sure. So you guys, it's over 4 pieces, right? Because we're breaking this piece up into 1, 2, 3, 4. And you said it's 1, 2, 3 out of the 4.
Yeah.
Perfect. I can't fool you guys anymore. You guys are getting very confident. I like it. Okay? And then what would this one be then?
3.
What'd you say?
370?
Oh, 370?
No,
315.
but that's not correct.
Yeah. I thought you said 7 pi, so I was like, ah!
Is it 315?
315.
That's what I missed.
Yeah.
That's what you said.
Right.
You meant 7 pi though, right?
Yeah.
Over 8?
Yeah.
No.
No.
Over 4. Thank you. You guys are so confident. And I kept messing this. I messed with you too much, I guess. All right. Yes, 7 pi over 4. 7 pi over 4, 315, right? And then if you wanted to write down those other ones for 1, when would theta be 1? When would tangent of theta be, what would the theta have to be for the tangent to be 1? So we got 45 and pi over 4, right? And then this one's 4 plus 1 is 5 pi over 4, right? And then, see, it's easier to do the pi's than it is to do the 45 plus 180, huh?
It is.
So, but it's 225. Okay? So, I'm glad that it's getting easier to do the pi's. That means that you're really understanding the unit circle. You're really starting to get it. That it's just broken up into pieces. These are kind of the hardest ones. The tangents. Okay? So, good job on that. Any questions on that? Good? Okay.